Hello students. Today we will talk about the distribution of oceans and continents. In this topic we will talk about the continental drift theory. We will also talk about the evidences in support of this hypothesis and the new theories which emerged after the continental drift theory. We will have a look at the ocean floor configuration, and we will also talk about the convection current theory in a little short form. Now, if we have a look at the world map, you can see almost 29% of the surface of the earth is covered with continents. Now, the position of the continents and the ocean bodies as we see them today in the map has not been there in the past. If we have a closer look at this map, we can see that there are some striking similarities which we can notice with respect to the positions of different continents. Now, if this was not the position what the continents have at present, then the two questions arise: what was the position earlier, and when, how and why did they move from their usual positions? One of the explanations, earliest explanations to this was given by Alfred Wegener in 1912 when he talked about the concept what we call as continental drift theory. According to Wegener, all the continents formed a single continental landmass known as Pangaea, and this was surrounded by a mega ocean what we call as Panthalassa. Around 200 million years ago, the supercontinent Pangaea began to split. This first broke into two large continental masses, Laurasia and Gondwana land. Laurasia forming the northern part and the Gondwana land forming the southern components respectively. And subsequently, Laurasia and Gondwana land continued to break into various smaller continents that exist today. You can have a look at this map to see how this Pangaea began to break. Now, there were some evidences in support of the continental drift which he put forth. He gave the concept of jigsaw fate, wherein the shorelines of Africa and South America facing each other have a remarkable and unmistakable match. He talked about the age of some rocks having the similar age across the oceans. Then he also talked about the tillite, that is the sedimentary rocks formed out of the deposits of glaciers which are found on Gondwana system of sediments from India, is known to have its counterpart in 6 different land masses of the southern hemisphere. How would this have been possible if these would not have once been part of the same land mass? This clearly demonstrates that leads remarkable similar histories of the land masses. Placer deposits, the occurrence of rich placer deposits in the gold in the Ghana coast, and the absolute absence of surface rocks in the region is an amazing fact. The fossils have also been found across the India, Madagascar and Africa, and they also are considered to have similar striking similarities. This is the diagram which depicts the fragmentation of the Pangaea into different parts and their wandering of these continents over a period of time. If you see this diagram, you can see how the present day continents have changed their position over the period of history. With respect to the force of the drift, what was responsible for drifting of these continents. Alfred Wegener put forth that there were two main forces which were responsible for drifting. One was the pole fleeing force and other was the tidal force. Pole fleeing force relates to the rotation of the earth, while as the tidal force is due to the gravitational attraction of the moon and the sun, and which the tides develop tides in the oceanic waters. Wegener argued that these were the forces which were effective when applied over millions of years. However, other scientists were not convinced about that these forces would be responsible to bring in such a huge change with respect to the movement of the continents. And a number of new studies came after the Wegener put forth his theory. One of the most convincing theories about this was the convectional current theory put forth by Arthur Holmes in 1930. It discussed the possibility of convection currents operating in the mantle portion of the earth as one of the forces responsible for drifting of the continents. He said that these currents are generated due to the radioactive elements causing thermal differences in the mantle portion. Holmes argued that there exists a system of such currents in the entire mantle of the earth. When later on expeditions to map the oceanic flow in the post-war period provided a detailed picture of the ocean flow. It indicates the existence of submerged mountains and trenches, mid-oceanic ridges in the ocean flow. These provided enormous information about the topography of the ocean, and as such the dating of the rocks took place, which talked about the age of the oceanic rocks. It was also found that oceanic rocks were much younger in age as compared to the continental rocks. When we talk about the ocean floor configuration, there are continental margins. These are the transitional zones between continental shores and the deep sea basins. They include continental shelf, slope, continental rise and deep oceanic trenches, the basal plain, the mid-oceanic ridges, and of course other similar features and forms. If we have a look at the distribution of the earthquakes and volcanoes on the world map, you can see that we have a striking similarity with respect to the line of central parts of Atlantic Ocean almost parallel to the coastlines. A line of dots, you can see it over here. Now these volcanic spots and volcanic eruptions and hot spots are of course extend the Indian Ocean. It bifurcates a little south of the Indian subcontinent, with one branch moving into East Africa and other meeting a similar line from the Myanmar to New Guinea. Now the shaded belt shows another area of concentration, coincides with the alpine Himalayan system and the rim of the Pacific Ocean. The map of volcanoes also shows a similar pattern. Now these all features point towards the distribution of the mid-oceanic ridge almost coinciding with the shallow earthquake centers in the oceans. It mainly gives an idea that the rim of Pacific is also the ring of fire, because there are active volcanoes in this region. Mapping of the ocean floors has given a new dimension to the study of the distribution of oceans and continents. Expeditions to map the oceanic flow in the post-war period provided a detailed picture of the oceanic relief. It indicated the existence of submerged mountain ranges, deep trenches, mostly located closer to the continental margins. The mid-oceanic ridges were found to be most active in terms of volcanic eruptions. The dating of the rocks from the oceanic crust revealed the fact that the latter is much younger than the continental areas. It gave us some evidence that there is some activity taking place in the oceans where the continental crust is thinner. Rocks on either side of the crest of oceanic ridges are having equidistant locations from the crust were found to have remarkable similarities both in terms of their constituents and their age. And when ocean floor configurations are taken into consideration, we find that continental margins form the transition between the continental shores and deep sea basins. They include the continental shelf, continental slope, continental rise, and deep oceanic trenches. Deep sea trenches are the areas where we have considerable interest as far as the distribution of oceans and continents is concerned. The abyssal plains, these are extensive plains that lie between the margins of the continental margins and the oceanic ridges. The abyssal plains are the areas where continental sediments that move beyond the margins get deposited. Mid-oceanic ridges are the form of interconnected change of mountain systems within the oceans. Its greatest example is the Mid-Atlantic Ridge. It is the longest mountain change on the surface of the earth, though submerged under the ocean waters. It is characterized by a central rift system at the crest, a fractioned plateau, and a flank zone all along its length. And if we look at the distribution of earthquakes and volcanoes on the world map, you can see that a line of dots in the central part of the Atlantic Ocean is almost parallel to the coastlines. It further extends into the Indian Ocean. This line of dots coincides with the mid-oceanic ridges. It gave scientists an idea that there is some activity happening in the oceans, and that may perhaps give an idea about the movement of the plates, and that brings into focus the sea floor spreading and the concept of plate tectonics, which we will be doing in a later topic. Now let us have a quick recap of what all we talked about today. We talked about the concept of continental drift. We talked about evidences in sport of the drift, for example, the striking similarities between the continents, rocks of the similar age. We talked about the glacier delight, talked about placer deposits. We also talked about distribution of forces. We talked about the forces which are responsible for drifting of these continents and the convection current theories, which gave a new direction to the continental drift theory. We also talked about the ocean floor configuration and the striking similarities of the earthquake and volcanic hotspots having a striking similarity with the plate margins. Thank you.